can just.
If you have a link, you can put it in.
Should
All
we
right.
mute ourselves?
Yes, you can mute yourselves. All the other speakers, all the attendees are muted. They'll be able to raise their hand to ask questions. We're going to get started, and we have a great panel, so we want to start on time and let everyone reclaim their time at noon. So let me just say good morning to everyone. Good to see you all from all over the country. Antoine Thompson, Executive Director for the Greater Washington Region Clean Cities Coalition. We have a great group of folks assembled here today. We're going to talk about renewable natural gas. You know, in the country right now, there's such a big focus on renewable energy, the role that it can play in climate solutions. And so this is a very timely discussion. And so this group of panelists will shed a lot of good information. You all have a good opportunity after they give their opening remarks. We'll have opportunity for you to put some questions in the chat as well. And then this presentation will be available on our YouTube page as well. And so we look forward to that, to this great discussion. So I just want to take a quick moment and introduce our speakers today, very accomplished individuals. They have been in the renewable natural gas and natural gas space for a long time. And these bios are just a summary. So they have very extensive bios, but we want to get to the meat and potatoes of today. Jeff Clark serves as General Counsel and Director of Regulatory Affairs for NGVA. NGV America is the National Trade Association dedicated to promoting natural gas as a transportation motor fuel. Mr. Clark has extensive experience in energy policy and regulatory affairs, having previously worked in government relations for the American Gas Association as well. Prior to joining NGV America in 2006, he worked for New West Technologies, served as a senior project manager. He also previously worked in the Washington office of the National Renewable Energy Lab, serving as a policy analyst supporting transportation programs for the United States Department of Energy Office, Efficiency and Renewable Energy. He has a JD from the University of Baltimore and an undergraduate degree from James Madison University. Marianne Mintz is with Argonne National Laboratory, is Principal Energy Analyst with Argonne National Laboratory's Energy Systems Division. She has over 40 years experience in transportation, energy analysis, and has authored over 120 publications in the field. Her current work centers on infrastructure requirements and impacts of alternative fuels, especially renewable natural gas, electricity, and hydrogen. Robert Taylor, WSSC Water. Robert Taylor is a professional engineer and CEM, has been an energy manager for WSSC Water since 2000, which is located in Prince George's County, Maryland. Is one of his main offices. Mr. Taylor is responsible for managing $20 million annually energy budget by optimizing supply and demand side energy optimization strategies, including upgrading inefficient equipment, load shifting, distributed generation, and financing, hedging in a real-time wholesale electricity market. He was instrumental in the development of WSSC's 10-year direct wind power purchase agreements for 30% of its electricity consumption, a 20-year solar purchasing power agreement. I like that. I did a lot on solar in my previous life. And so let me just read the last couple of things on him. He has a BS in civil engineering from Lehigh University, Maryland, and an MBA from the University of Connecticut. All right, Maria De La Orden is with Galileo Technologies. She's an expert in renewable natural gas. For the last 18 years, last few years, she has been supporting Galileo Technologies in the project development for Galileo's biogas upgrading and compression products. She brings more than 30 years of natural gas technologies experience, optimizing the upgrade and compression system to minimize power consumption and construction time to maximize project revenue. As I stated earlier, she's an expert in natural gas and brings experience and knowledge to the renewable natural gas leadership team. All right, so this is our dynamic group of folks. Let's give a virtual hand clap for them as well. Virtual hand clap for our speakers. Thank you all for taking time out of your busy schedules. You could be anywhere, but you chose to be with us today. So thank you for being here. We'll get right into it. Our first speaker is Jeff Clark with NGV America. Jeffrey.
All right, thank you. I think the slides will be coming up here in a sec. So as we're waiting for that, yep, thank you. I appreciate the opportunity to be here today and to talk about a subject that we love to talk about, renewable natural gas. And so thank you for the invitation. And if we could go to the next slide, please. I want to thank all our members for supporting NGV America and the work that we do and allowing us to work in this field. Our members include utilities, fueling station operators, vehicle manufacturers, equipment suppliers, and fleets. And so thank you to them. Next slide, please. So I'm talking about natural gas and renewable natural gas. I think it's great to highlight some of the major companies around the country that are using natural gas and transportation, renewable natural gas. So as you can see here, these are some of the industry leaders. Waste Management, UPS have been industry leaders for many, many years. And then Frito-Lay, Anheuser-Busch, and most recently, Amazon is running natural gas and RNG in their fleets. Next slide, please. So just some of the additional major companies and more examples of companies that are using renewable natural gas as part of their transportation programs. Next slide, please. So in working with people, most people today, they want to know what are the emission reductions I can get with natural gas and renewable natural gas when using them in our fleet. So we like to use these tools, and this is from Argonne National Laboratory. Marianne's going to be talking in a few minutes, and they provide a great suite of tools to help fleets determine the emission benefits, emission results of different alternative fuels. You can figure out how much your emissions are going to be over the life of a project, or you can figure out what your reductions are going to be using these different tools. And so we really like to point people in the direction of using these online tools. They're very user-friendly. You very quickly do emission calculations with them. So highly recommend these. We also point folks to the California website where you can see what the carbon intensity scores of different alternative fuels are. We're very proud of the fact that if you see the bio-CNG number in the bottom here, in the bottom right, most recent quarter data shows that it's -62. That's a negative number, so it's carbon negative. And natural gas, bio-CNG has been carbon negative now for the last 4 quarters of the last year in California. That's quite an achievement. Next slide, please. How important is RNG to our industry? Well, as you can see from this slide and the fact sheet that we put in the chat, RNG accounted for 53% of all natural gas used in on-road transportation in 2020. So more than 50%, so that's a huge achievement. And RNG really, if you look back a few years ago, it was just in its infancy in terms of being used in transportation, but it's grown by 250% in the last 5 years. And as you can see that growth in those charts, those that data is from the US EPA's Renewable Fuel Program. And I just pulled the most recent data for 2021. And we'll see that 580 million ethanol gallon equivalents of natural gas was consumed in 2021. We don't have our latest figures on the percentage of fuel used in on road, but I'm thinking that it's going to be somewhere around 75%. I wouldn't be surprised to see something as high as 75% in 2021. So next slide, please. Also important to highlight, in addition to the environmental benefits, the economic benefits of using renewable natural gas. Guidehouse did a study for the RNG Coalition that was released in December of last year, and that showed that in 2021, RNG contributed 22,600 jobs and 2.6 billion toward US gross domestic product. And then if you look at what the RNG Coalition is expecting by 2030, they're expecting 800 new facilities to come online with the potential for 100,000 new jobs. This is a study that's available at this link, and it's very new. It came out in December. Next slide, please. It's also important to point out with renewable natural gas, unlike conventional natural gas, there are 33 states that produce conventional natural gas in the US. Folks are probably very familiar with Texas and Oklahoma and Pennsylvania are major producers of conventional natural gas, but RNG projects can be produced anywhere in the US. All 50 states have the potential to produce renewable natural gas. And Marianne's gonna provide us some updated figures, I believe, but as you can see here, we have projects all across the country, 200 operational RNG facilities in the US, 155 planned, 155 planned or under construction, and then even more planned. So next slide, please. One of the major drivers for RNG, in addition to the federal RFS program or Renewable Fuel Standard program, is the state's efforts with the low carbon fuel standard. It started in California and then moved up the West Coast, Oregon and Washington. And now, as you can see from this map from our member company, Clean Energy, many more states are looking at adopting clean fuel standards or low carbon fuel standard. This is a great occurrence for our industry, and we think it's really going to grow the market for renewable natural gas as it provides demand for increased RNG. Next slide, please. I'm going to turn my attention a little bit to that fuel has to go somewhere. We've got to use it in vehicles. I showed some great pictures of vehicles at the outset. What we have is we have a great solution for medium and heavy duty trucks. Cummins, if you look at their engine, they have a suite of products that can meet all the different applications for medium and heavy duty vehicles. All these engines are certified to the low NOx standard, which is 0.02. That is a standard that the US EPA is currently considering adopting as the national standard, but right now it's a voluntary standard. And it's not likely to go into effect until 2027. So we have product today that running with RNG is carbon neutral, and running with RNG can meet the most demanding NOx standard. Next slide, please. We have a new product that's coming out in the next couple of years. We're going to see the 15 liter. Why is that important? Because it's important because it means we're going to have a large enough engine to pull Class 8 trucks full of 80,000 pounds, operating in the most strenuous conditions. This is something our industry has indicated we need, and now it's coming. This product is going to be in demonstration soon with fleets, and Cummins is saying that they're going to have a 10% fuel economy improvement with this engine. So we're very excited about that. Next slide, please. The benefit of natural gas in transportation is that our engines are able to meet the strenuous emission standard with very simple after treatment control technology, very much like what we use in our light duty three-way catalyst. And so we do not use SCR systems, so we have no regen downtime. This is essentially a maintenance-free system with no filters, easy, no filters to clean or replace, and no DEF fluid. Next slide, please. And another great development is the advent of hybrid trucks. This is a product that's available today in the marketplace as a retrofit. You can take an existing truck and retrofit it with a hybrid system that can run with the natural gas and batteries. Next slide, please. And this is another product that's available from Hyliion. That's going to be their Hyper ERX, which is coming out soon. This product actually operates as a genset with the natural gas engine providing electricity, and then electricity powering the vehicle. Has a all electric drive capability of 75 miles, which is important in urban areas and port facilities and other places where you will want zero tailpipe emissions. Has a 1,000-mile driving range. Next slide, please. So in wrapping up and in concluding, I think the takeaways here are that with natural gas and RNG, we have a solution that's available today. It's deployable, it's scalable. We have fuel that's carbon negative, as we pointed out with the Bio-CNG in California. All of our products meet the low NOx standard, and we have trucks that can go 500 miles, 800 miles. And so we have a solution we think that fits a number of different important applications. And thank you very much for your time.
A lot of great information, Jeff. I got a number of questions, but we'll hold our questions to the end. But a lot of great information. I hope that people are paying attention and taking notes. Great information. Next, we'll go to Marianne, who is well-versed, over 100 articles in this space. So thank you, Marianne.
Hi, thank you, Antoine. I'm going to turn off my video so that I don't have any bandwidth issues. Okay. Kimberly? Great. Okay. So we're going to focus today on heavy-duty vehicles, though RNG can be used elsewhere. The focus, Jeff already keyed us up, is on heavy-duty vehicles. Next slide, please. Just filling in a few things around what Jeff started with. Just a very quick definition about what RNG is and why do we care. As he said, it's a drop-in renewable fuel for natural gas engines, and it's basically produced as organic waste decomposes. It releases a biogas, and that biogas is anywhere from 40 to 60, maybe even 65% methane. And that gas can be refined or purified, if you will, to remove contaminants and increase its heat content, its BTUs. And the result is what we call renewable natural gas or biomethane. And as we said, it can be used in place of or mingled with fossil natural gas. Next, please. And as Jeff said, there are a number of benefits, and from the fact that it's from renewable feedstocks, it's diverse, it's not intermittent like solar and many other renewable fuels. Economic benefits, it's a transition fuel, and most importantly, next, please. It cuts greenhouse gas emissions, and I'm going to really focus more on that particular aspect. Next, please. Now, this image comes from a document that we've recently released, and I'll put the link in the chat in a couple of minutes. It compares various fuels on a well-to-wheel basis, basically using the carbon intensity that the California folks like to use. And that measure is grams of CO2 equivalent per megajoule. And it includes both the production and the use of the vehicle. And these numbers came from the GREET model for generic pathways for each of these fuel types in a heavy-duty diesel engine, using the A-fleet model to model the use of fuel on the road. And so these are generic pathways, and so they're not exactly the same as what you'll see from the folks in California, where they're actually reporting actual values that were obtained by a particular project that produced renewable natural gas for 6 months. And so those numbers will be specific to a particular project, whereas these are generic. And just walking you through it, low sulfur diesel and fossil CNG, when we adjust for the efficiency of the engine and look and calculate the carbon intensity, they're basically equivalent. Electricity is less for the US mix and even less for the California mix. And as I should probably indicate that I'm working across from left to right. Renewable diesel from soy is pretty comparable to electricity in California, as is landfill gas. And those are much better than fossil natural gas or low sulfur diesel. But when you move to the right and get into some of these other RNG pathways, that's where you see the negative values, particularly for manure-based pathways, where the RNG is produced from the waste from the animals. And it could be dairy farms, it could be pig farms, it could be chicken farms, could even be cattle operations, confined animal feeding operations. And it also will depend upon how the waste was handled in the past. And so that's why we're showing a range there. Those blue lines can be anywhere from well over minus 200 in carbon intensity to just slightly negative. And then moving to the right, we see two other options, producing renewable natural gas from wastewater treatment plants, which is also negative, and from food waste, which is also negative. So basically the point, next please. The point is that renewable natural gas pathways are very attractive in terms of their carbon intensity, and negative carbon intensity scores can occur if renewable natural gas avoids previously emitted methane, because methane has a very damaging global warming potential. It's much worse than CO2. Next slide, please. Okay, so basically, Jeff alluded to the fact that we've been monitoring projects that produce renewable natural gas only for transportation. We've been conducting this survey, if you will, over the last 5 years. We started in 2017, we've done it in 2019, 2020, and we've just completed the 2021 update. These numbers are not yet posted online. I'm hoping that they'll be up in the next week or so. But basically, over those 5 years, we've gone from 112 total projects, operational, under construction, or planned, to over 400. And that number is a little bit higher than what Jeff indicated a few minutes ago, because it goes to a little bit farther along. It's basically through the end of 2021. And that 418 total projects, in terms of the ones that are operational, they have a potential production of over 600 million gasoline gallon equivalents. And that's bigger than what Jeff said earlier, because that's the potential production. It's what their capacity is. Next, please. And this graph here, next. The graph shows the growth in the operational projects from 2017 through 2021, where we started with 60 that were operational. We're now around 230. And this also shows the breakdown of what kind of projects they are, whether they came from landfills, livestock and agriculture, food waste, or wastewater treatment plants, that what we call water resource reclamation facilities, or WRFs. You see big growth in the ag projects, which is the green line, the green bar. Next, please. And in terms of the production capacity, following through on that the growth in the green bar, you can see how it's increased between 2017 and 2021. In 2017, over 85% of the renewable natural gas came from landfills. Last year, it was a little under 75%. Next slide, please. Now, the production capacity has grown nearly 250% over that 5-year period. And this is, again, the reported capacity. You can see how it's increased for each of the sources, for landfills, food waste, and livestock, ag, and worse. You see that big increase for agriculture. And these numbers include the potential output of new projects that were expected to come online by the end of 2021. They were not all in operation when we finished the data collection, but they were far enough in the process of being commissioned that we concluded that they would be online by the end of the year. Next, please. And the reason for that increased growth is, a lot of improvements in the economics. The scale of projects has grown. They tend to be bigger, especially for livestock and ag projects, where they're now clustering several farms together and basically combining the animal waste into one single digester. So that increases improves the economics for the project. There's also been a lot of improvement in the interconnection process for getting that natural gas, that renewable natural gas, into the natural gas pipeline network. There's increased demand, as Jeff said. A lot of fleets are now interested in using that renewable natural gas, and there's increased numbers of vehicles that can use it. Additional financing sources. I mentioned before that now they're able to get 10-year contracts for some of these projects. And so there's a lot more interest, and it's much easier to get these projects financed. They're not cheap. And lastly, a lot of incentives have encouraged the growth of renewable natural gas, and we'll go into that now. Next slide, please. This chart shows the change in the last 5 years in the price that the credit price for what we call a D3 RIN, which is under the Renewable Fuel Standard, RFS2. It incentivizes RNG as a vehicle fuel. And that incentive right now is about $3.40 for each ethanol gallon equivalent. That's what a RIN is measured in ethanol gallon equivalents. And that equates to about $5 per diesel gallon equivalent. Big incentive. And that's in addition to what can be obtained from state incentives. So you can see that the green line on the chart on the left, you can see it fluctuated up and down. It was a big drop in the middle in 2019 when a number of, there was an issue because the demand dropped because of exemptions that were granted for the obligated parties under the Renewable Fuel Standard. But it's recovered, and it's now, as I said, up around $3.40. And on the right, you see how that value, the $3.40 is over $40 in terms of dollars per million BTU, and that compares to natural gas, which is right around $10 or even less. So it's a big incentive. Next, please. And as I said, California and Oregon have their own credit systems, as Jeff was mentioning, and they're stackable, meaning that producers can get those credits, the value of those credits, as well as these renewable fuel standard credits. And so that has pulled the low carbon intensive RNG to California and Oregon markets, which enables them to achieve ever lower carbon intensities in their fuel pool, which is what the low carbon fuel standards are all about. Every year, the fuel retailers have to reduce the amount of carbon in their fuel pool. And so by incorporating more renewable natural gas, particularly the negative CI gas that you see with the ag projects, that's how they're able to achieve the standards that are required. And like oil, the credit markets can be volatile, but 10-year fixed price contracts are becoming more common, and that's also encouraging production. Next slide, please. As we all know, heavy duty transport is hard to decarbonize. And RNG is an available, affordable decarbonization option in the near term. And I think Jeff went through many of the benefits, and I'm just going to summarize a few of them. It converts methane that had been emitted or burned as waste into a fuel that can displace highway diesel, which, as we know, is quite polluting, not only in terms of greenhouse gases, but in terms of tailpipe emissions. It's a drop-in fuel for natural gas vehicles. And as Jeff showed us, there are a number of vehicles that are already on the market and others that are on the way. It's a zero carbon or potentially carbon negative if methane emissions are avoided. It's increasingly available from regional and national suppliers, as are the natural gas vehicles to use it. And it's price competitive to fossil CNG and diesel with various government incentives. Next slide, please. And with that, I thank you.
Thank you, Mary Ann. You definitely know your stuff and definitely have a number of questions for you. That one chart really said a lot, the food stocks compared to landfills. So definitely want to ask you about that
I just sent the link.
That's sourcing. So, oh, thank you. Thank you. Next, we're going to go to folks who've got some projects, who are taking all this theory and all this information and putting it to work to impact the industry, the climate as well. Robert Taylor, WSSC, you got some major projects going on and really making a difference there in the greater Washington area.
Thank you, Antoine. First slide.
1 second.
Okay. Well, in the meantime, before we begin, that's not mine, but there we go. I want to be talking today about WSSC Water's bioenergy project. It's the largest capital project we've ever undertaken. Capital cost is nearing 300 million. And I'll spend the next few minutes talking about some of the details and what led up to the project. Next slide. Just a little about WSSC Water, who we are. We're a water and wastewater utility serving Montgomery and Prince George's counties in Maryland. We serve a population of 1.8 million. We provide 170 million gallons a day of drinking water to our population, to our ratepayers, and we collect 200 million gallons a day of wastewater. We treat 70 million gallons a day of that, and we supply DC water with the rest. On the right-hand side, upper right-hand side, is a list of all of our assets. The one that I'm going to be talking today specifically is the 5 water resource recovery plants, which Marianne pointed out used to be called wastewater treatment plants before we realized that there was a major energy source in the wastewater that could be converted. Next slide, please. The reason for the project I've listed on this slide, the reason is based on biosolids disposal. Biosolids is the solids left over after wastewater treatment. And Maryland has instituted stricter state regulations starting in 2016. They banned land application in the winter and restricted the land application during the fall, plus added regulatory restrictions for phosphorus. Land application is the main source of application for biosolids. And also in other states, Pennsylvania, Virginia, and other nearby states are expected to toughen land application regulations due to a growing number of biosolids hauls from Maryland. Next slide, please. The long-term outlook is land application will become more expensive due to longer hauling distances and possible winter storage costs. So that was the initial driver for the project, which turned into renewable energy project in the development. Next slide, please. So a few bullets about the project. Anaerobic digestion is the process that digests the solids and turns it into renewable natural gas or methane, which is cleaned up. We're going to be trucking biosolids from our Seneca, Damascus, and Parkway plants to a central location at the Piscataway Wastewater Treatment Plant, or I should have said Piscataway Water Resource Recovery Facility. The anaerobic digestion will convert the biosolids into methane gas and reduces the volume by half. And it also converts it into a Class A biosolids, which we hope to turn into commercially sold fertilizer, similar to DC Water's Bloom product. And the methane is used as the fuel to power clean burning engines. That was the original purpose, but we modified the process to produce electricity and heat for the plant through the natural gas and selling the renewable natural gas to a local transit authority that we're still negotiating with. Next slide. This is the aerial view of the existing site, the Piscataway Water Resource Recovery Facility. Processes about 30 million gallons a day of wastewater. It's located at in southern Prince George's County, at the corner of Route 210, Indian Head Highway, and Farmington Road. Next slide. The photograph shown in this slide shows the construction progress, which is now about 50% complete. It's expected to be operational in the 2023-2024 timeframe. So the project will digest solids from as I mentioned before, 5 water resource recovery facilities, provide process heat and plant power from 3 1.5 megawatt natural gas fired engines. One is standby, but all 3 of them can be used. And again, converting all the biogas to renewable natural gas for the fleet fuel. Next slide. Not to get too technical, but this shows a schematic of the piping and asset configuration. If you look at the right-hand side, the biogas is produced from the plant. It's upgraded into pipeline quality biogas, and it's ported to through meter number 2, which is injected in Washington Gas Pipeline's high pressure 300 PSI system. Meter 1 is the incoming natural gas, which is used to fuel the engine generators, which again produces power for the plant and also steam for this, not only the digesters, but the Canby system, which is a pre-treatment system prior to going into the digesters. The alternate route, if in fact the renewable natural gas market dries up, which we don't anticipate, we can always use that renewable natural gas to fuel our engine generators. And going out through meter 2 on the left, it goes through the Washington Gas Pipeline through the city gate and onto the customer. So our purpose is to sell the cleaned up biogas to a transit fleet and also sell the renewable fuel credits, which Marianne pointed out as being RINs, to gas and oil refineries. Now, the gas and oil refineries are required by EPA to purchase or own a certain quantity of RINs per year. That's set by EPA, and as Marianne showed in her previous slide, the price is going up and is about $3.50 gallon of ethanol equivalent. Next slide. We had to spend quite a bit of time negotiating with Washington Gas Light, WGL. As you all know, they're the exclusive natural gas utility for most of the metropolitan DC area. And they're also regulated by the Maryland Public Service Commission. We had to negotiate a contract for the expansion of their pipelines to include the Piscataway bioenergy plant because there was no gas on site. Although there was gas lines near the site, there was no gas on site. So we had to negotiate a price for WGL to run their pipelines, and also we had to negotiate the use of their infrastructure for the conveyance of natural gas to the bioenergy plant, and also the conveyance of renewable natural gas away from the bioenergy plant to an external customer. So this whole process took, I would say, a few years. It's WGL's first renewable natural gas project, so that's probably why it took so long, but it was finally finished about a year ago. Next slide. So I won't go through all the items included in the contract. I will say that the renewable natural gas quality specs and sampling specs were quite strict as set by Washington Gas Light. So we spent quite a bit of time negotiating with them on the exact specs and the sampling specs. The contract was finalized and it had to go to the Maryland Public Service Commission last year, and it was approved in November of 2020. Next. Some other, whoops, if you could go back, Kim. Some other contracts that we've had to engage. We had to register with EPA Central Data Exchange for new renewable fuel producer. That's been completed. EPA requires a RIN verification consultant, a third party, that we procured, and that's been awarded. They're underway now. And we also are negotiating with the transit bus fleet for the energy sale of the RNG. That's underway. That should be completed. I can announce the name in about 30 to 60 days, but I can't yet because negotiations are underway and will be completed soon. And the sale of D3 RINs, cellulosic RINs, to an obligated party, which will be an oil or gas refiner like BP or Shell or a company like that. We'll advertise that within a year of started. And lastly, we to lower our cost to not only supply gas but also supply from supplier, but to also supply gas to our transit fleet. We applied and got approval from the Maryland Public Service Commission for the supply gas license. So we become our own gas supplier. Next slide. And that concludes my presentation. As Antoine mentioned, we'll take questions at the end of all the presentations.
Yes, we got about 5 questions in the chat, and I got a couple. So we're gonna, once we hear from all this great information from Maria, we'll get right into the questions. Maria, the floor is yours. Welcome.
Hi, everyone. What a great panel. This has been amazing. Really learning a lot. So while my presentation loads, I'll give a little bit of background and go, we do gas compressors and gas technology. So we have the upgrading portion of what Rob was just talking about. We carry that technology. And I don't know if we can see my presentation yet. Oh, there we are. So the core of what we do is modular, and we, when you look at, we can go through to the first one. I think the first couple are just kind of titles. So we go to the next one. So we have a challenge that is the target to reduce greenhouse gases. And I think it's what everybody's been talking about. And so far, the industry, like we can see in the next slide, I have a lot of slides, so I'm going to move a little fast through the first few. The industry has been focused mostly in dairy farms, in the larger dairy farms. And when you look at the amount of large dairy farms, they're very little. Or not very little. There's about 700 as of 2017, and the other side, the other part of this landfill gas, which is a whole different animal that I'm not going to discuss today. We can discuss some other day. But the industry has been focused in this large farms because I think what Marianne was talking about, there's certain economies of scale that I'm going to talk about in a little bit here. So if we go to the next scale slide. So we think that this will be the next challenge, is the small applications. And when we talk about small dairy farms, that would include also smaller swine farms, wastewater treatment plants, anything of a smaller scale that has some challenges as far as downscaling the technology, the upgrading technology. And we can go to the next one. So far, the main challenge to downgrade to this smaller farm has been the pipeline access. And like Marianne, I think, mentioned that. And the pipeline interconnection is a very long process and very expensive. I think that is turning a corner here, and we're seeing more and more accessibility to different injection points for the RNG in the pipeline. So what we bring into the table as Galileo is we bring the upgrading for a smaller scale. So we can go to the next one, which is just, yeah. So the Biobox is our smallest possible scale for upgrading and compression. And it takes the gas directly from the digester, 70 SCFM, which is very little. 70 SCFM would be about 1,500 heads of cows, or maybe 15,000 swine farm, or a small size wastewater treatment plant. And the beauty of our modular technology is that you can put two in parallel if you have more, and then the system also has a turn down of about 40%. So we believe that the next big wave in the RNG market is going to be the smaller applications. A lot of what they're doing right now is they're trucking the manure or the waste into a centralized location, and from there doing the upgrade. And what we propose is do it differently. So you're not trucking so much waste, but you're trucking actually the pipeline quality gas at that point. We can go to the next one. So our technology it's all plug and play. It comes like that, takes a very little space. We can partner up with a digester company if there's not a digester or a legroom that we can take the biogas from, and do also a very small digester associated with this. We can go to the next one. So this is kind of the overview of how the project would work. We'll have the Biobox on each farm with the yellow modules are the virtual pipeline for the CNG, and the Biobox in each farm will completely upgrade the gas. Most of the gas would not, it says they're partially removed, but most of that's for other types of gas. For any kind of farm digester or wastewater treatment plant gas, we would completely upgrade it at the farm, and then we can transport it to a centralized location where we do the final upgrading. We can go to the next one. So these are all about the virtual pipeline, which is the key component. You know, a lot of these farms don't have a pipeline injection, and that has been limited the access to doing biogas at the farm. So basically, you know, a lot of farmers that have big farms or can concentrate several farms in an area, or big wastewater treatment plants have been getting royalties and have been getting benefiting from the biogas economy. And we think that there's a lot to be done regionally, bringing this to each community in the country, bringing the ability for the small farmer to also benefit from that. And then that, I think it was Jeff that mentioned how there's regionally, there's so many, there's biogas anywhere you look. Every community has biogas, and our goal is to make sure that they can upgrade it and use it. And we have, you know, this is our smaller unit, but we have a whole range of products that will allow them in a very modular way to exercise the ability to upgrade and use that gas. I think we can go to the next one. And this is pretty much about talking about the virtual pipeline, also how our modular virtual pipeline will allow for this too. Mostly the most expensive, one of the biggest costs, the two biggest costs you have when you're doing an upgrade project from any kind of digester or farm would be electricity, would be the first one, and the second will be transportation of the gas to an injection point. So we try to minimize those two with a more creative way to handle the virtual pipeline with our modules. And then as far as the power consumption, the fact that we have our own compressor technology, it allows us to integrate the compressor with the upgrading membranes. We use a 3-stage membranes system. It allows us to integrate the compressor with the membrane so we can reduce the power consumption too. So that way, again, projects that could have not been economically viable before because the cost of constructing a whole upgrading system, now with this system that has very little construction on site, everything comes pre-assembled, just drop it, connect it, and you're good to go, allows smaller farms or smaller applications to have access to a technology that has been available for the larger farms for a long time. I think that's about, oh, I have a few more of the virtual pipeline. The gas, once it is upgraded, like it's been said, it can be used for power generation, for vehicles. We can move the next one. We can move to the next one. I think that we're almost, the gas, once it's been upgraded, it can be used for power generation. It can be used for vehicles. It can be used for industrial facilities, communities. It can be used in any kind. And depending where the gas comes from, depending if it's a dairy farm, a swine farm, or a wastewater treatment plant, like Marianne said, it'll have a negative carbon footprint or a neutral carbon footprint. I think I have a couple more showing the virtual pipeline details. If we can move to the next one. The modules just that we have, the virtual pipeline modules, you can just move them from the trailer to the platform where they sit while they're loading from the upgrading unit, from the Biobox, very easily. You don't need a crane, you don't need anything. It's all hydraulic to move that. And the next one. And it requires a very, very small footprint, the upgrading system. Then we'll have digester that will depend on the amount of waste we have, but this will have a very, very small footprint. We have 2 units with a Microbox, which is our next size up in Wisconsin. It's a very compact system, integrated, only 1 compressor, everything integrated with the compressor. It's really very, very efficient. And like I said, I think the most groundbreaking thing about this is that it'll allow small farmers and small applications that have not been participating on the biogas economics, which is what the larger farms and the larger applications have been doing. It'll allow them to do that now. And that will, I think, exponentially increase the amount of biogas that we have available in the country, which of course will help us reach our carbon reduction goals. I think that's about it. Yeah, thank you very much.
All right, well, thank you, Maria. We're almost out of time. I want to give folks a chance to, we got a couple questions, so I want to give the folks on the panel a chance to answer the questions. So we got to move quickly. The first is there any other products that is needed that are added to NG, or is it just a neutral product? Does anyone want to answer that one? Mary Ann or any of you want to jump on for that?
I'll jump in. I think what we've been talking about is processing the gas to remove contaminants and things that would be bad for the pipeline or wouldn't be consistent with pipeline quality gas. So we're not adding anything other than the injection point into the gas system. We would be adding mercaptan, which is the odorant that folks are probably familiar with natural gas.
Thank you.
Yeah, I'll just add one thing. Actually, you can also have combinations or blends of RNG and fossil gas because they are interchangeable.
Yeah, sometimes the main limitation for RNG to inject in the pipeline, because it's just methane, it's the heating power. So some applications, I've seen some applications that if they don't remove, if they don't have a high purity of methane in the gas, up to 98 or 99 or more %, then they'll have to add propane to increase that heating power.
Yeah.
All right, thank you. The next question is from Cliff. How to take the first step in feasibility of extracting RNG from a municipal wastewater treatment plant that currently does not have anaerobic digesters? What initial questions must be addressed? Rob, you want to jump in?
Yeah,
there?
I can jump in on that. We had a feasibility study done to kick this project off about 7 years ago. And the size and capacity of the wastewater treatment plant is key. Ability or nearness to a gas pipeline might be another consideration, although Maria's product gets around that by transporting modules. And I'd say regulations are very critical, and but mostly the size of the plant and the processes involved, and if anaerobic digestion can be incorporated in the process.
All right, I want to take, anyone else want to jump in on that real quick before I go to the next question? We got 3 minutes, so. All right, here now we're going to go. Why is upgrade? This is from Emmanuel. Why is upgrading and pipelining the biogas a better solution than just running the biogas to a fuel cell on site and produce on-demand renewable electricity at a far higher efficiency than burning the RNG at a gas plant somewhere down the grid?
I can take that too, or start. Fuel cells are very expensive. The cells have to be replaced every 5 to 7 years, and it's just a very expensive way of producing electricity. Several facilities in California have done this and have had to replace the fuel cells and or had to abandon the fuel cell technology altogether. So I would say it's a matter of economics.
I would agree 100%. It's a matter of economics. Also, because electricity is a lot cheaper than renewable natural gas to sell. So it's just a matter of economics. You can, and that's what I don't want to diverse a lot from what we've discussed in here, but that has been the case with landfills. Landfills historically have been doing electricity with their RNG, and they've been moving in the past few years, especially the largest one, to producing RNG rather than electricity because they just get more money out of it. A lot of landfills were literally losing money over the electricity and are making money over the RNG.
Yeah, good point, Maria, because they get a very low return on the electricity that they sell to the grid. They're actually, it's usually better to just offset what they were buying.
Oh, wow.
Yeah.
All right, we got one more question. Is there anyone who I can connect with to discuss the possibility of introducing XTT's life's burn rate modifier that if added to natural gas will give better performance? That is from Vinny. So Vinny said, who can he contact about his product or what have you? Any, I guess you can email. Anyone want to jump in on that, or you want me to just he can put his
If
information in the chat.
Vinny can email me, Jeff Clark, we might be interested in that and understanding how that provides better performance.
Jeff, you want to put your information in the chat? All right, Marianne, I'm going to give you the last question because we're out of time. What role can renewable natural gas play in decarbonizing the economy? Some criticism of renewable natural gas as a climate strategy stems from concern they may distract from other vital carbonization strategies such as electrification. There's renewable natural gas is taking off. Your chart was excellent. Some purists in the climate movement see this as a distraction. What do you say to them?
Basically, what I say is it's a near-term drop-in option. The fact is, on the long term, electrification may be the way we go, but it's not here now for heavy-duty trucks. And an RNG is a way of capturing methane that otherwise would have been emitted. And so that's where you get that carbon negative benefit. And it also is something that's here now, and it can have an immediate effect. That would be my best answer.
Thank you. Thank you. I want to thank this awesome panel. Every time I read up and talk with you all, I learned so much. As a 20-year-old, I had the opportunity to be an intern at National Fuel Gas on the 17th floor of downtown Buffalo and track future stocks, and have studied and had a lot of very interesting experiences with the various forms of natural gas. So thank you all. You've been a great, provided some great information. I hope that you all will come back to all of the attendees. I'm sorry we are out of time, but let's give this dynamic panel a virtual hand clap, and the presentations will be available. If you attended, we will email you their presentations, and this video will be on our YouTube page. You can go to Greater Washington Region Clean Cities, and it will be uploaded sometime between now and Friday. Take care, and thanks for being here today. Bye-bye.
Thank you, everyone.
Bye-bye. Thank you.
All right, thank you.
And join our organization too. You can join. We'll put that in the chat too. Thank you. Make sure to become a member.